Okay, today we're going to be doing 2.4, which is long division and synthetic division, and then we also have the remainder and factor theorems involved in this. So we're going to start with long division. This is a process used to divide two polynomials where the divisor can have any power or any leading coefficient. This is something that makes it different from synthetic division, so this is the default. If you can't do it using synthetic division, you can always use long division. So first of all, it says divide x squared plus 4x plus 3 by x plus 3. So this part is your divisor. What goes under is your dividend. And then your answer is your quotient, and then sometimes you have a remainder as well. So what we're going to do is we're going to do x plus 3 and divide it by x squared plus 4x plus 3. And we're going to use a process similar to regular long division with just numbers, but it's a little different. So what you're going to do is do x times what gives us x squared, because our whole goal is to subtract this and get it to be 0, so we would need x squared there. So again, what we can say is x times what is x squared, and that's x. And just like in division with numbers, you have to multiply back, so you're going to multiply both of those. So because there's two terms here, I like to write my subtraction signs to remind myself. So it's going to be x times x, which is x squared, and x times 3x, which is 3x. Now we're going to subtract, so those are going to cancel out, and positive 4x minus 3x is x. And just like in regular division, we bring down that next term. And then again, I'm going to say x times what is x, and that would just require a 1. And then I'm going to multiply that 1 back, so minus x minus 3. And this one ends up having a remainder of 0. The solution is our quotient, which is x plus 1. That's right here. We have a remainder of 0, so what this tells us is that x plus 3 is a factor of this polynomial. How do I know that? It's a factor if it divides evenly or if its remainder is 0. Okay? So moving on to the next one, you see this one gets a little bit more complicated than the last one. So go ahead and set it up. So 2x cubed plus 1. And then my caution for you is to be careful when you're looking at the terms and make sure that it's in order by descending powers of x. So notice right here this 2x to the 5th isn't. So it should be first and it's not. So I'm going to write 2x to the 5th minus 8x to the 4th plus 2x cubed plus x squared. And then if you recall from Algebra 2, you want to put plus 0x plus 0. So these are our placeholders. We need those there so that we can get the correct quotient. So 2x cubed times what is 2x to the 5th. So I'm going to show you a little different way in case you need help with this. You remember you're dividing, so if you do 2x to the 5th divided by 2x cubed, and simplify that, you get x squared. So that's what's going to go up here, and you're actually going to line it up with the proper place value, and in this case it would be x squared. So it's just going to be x squared, and then I have to multiply and subtract. So x squared times 2x cubed is 2x to the 5th, which is what I wanted, so I could cancel those. And then x squared times 1 is x squared, but I need to subtract that. So we did skip some terms, but it's okay because we'll just bring them down. Negative x to the 4th plus 2x cubed plus 0x squared now plus 0x plus 0. You don't have to bring these all the way down every single time, but it's just easier to keep track of it. So the next one is 2x cubed times what is negative 8x to the 4th. If you can do that in your head, great. You should be able to do that, but sometimes that's just a weird question. So remember, you can always fall back on this right here, taking this and dividing it by that term. and simplifying, so I get negative 4x. Now be careful when you ever have part of your quotient as negative, because we're going to be subtracting a negative number, which means we're going to be adding it. So up here, this is negative 4x, and then I'm going to go negative 4x times 2 is negative 8x to the 4th, but remember I'm subtracting negative 8x, so it becomes positive. And then negative 4x times 1 is negative 4x. However, I'm subtracting negative 4x, which means I'll actually be adding it. So when I start to bring this stuff down, this is where I'm at. Again, you can see why it would be important to have the 0 placeholder. The next one, I'm going to do 2x cubed times what is 2x cubed. You could probably do that in your head. You just need it to be 1, but to be consistent, I'm going to put it right there. So plus 1, so minus 2x cubed, and then minus 1. So these cancel, and I'm left with 0x squared plus 4x minus 1. And the question is 2x cubed times what is 0x squared? Once this number right here becomes less than this number right here, so the degree here is less than the degree here, you're done with the problem. And whatever's left over is your remainder. So you can see in the next little piece it tells us that when we write our answer, we're going to take the quotient, which is up here. So x squared minus 4x plus 1 plus your remainder over your divisor. So here is my remainder. I don't need to write the 0x squared because that's just 0. So plus my remainder over my divisor. So that's what I was dividing by. So this is my final answer for that example. So what I want to point out for this one is that 2x cubed plus 1 is not a factor of the polynomial we were given because we ended up with the remainder. The only time it is if we get a remainder of 0. So what I want you guys to do right now is pause the video and try this example on your own. I'm just going to go through it right now, but I would encourage you to try it to make sure you're picking up what we're putting down. So 3x plus 4 divided by, I'm not in order by powers of x, so I need to be careful to do that. So I get to there. 3x times what is 6x cubed, and just in case that's hard for you, it's going to be 2x squared. So up here above the x squared goes my 2x squared, and now I'm going here and here. So minus 6x cubed and then minus 8x squared, both minuses, so that's nice. And so then I get 9x squared plus 27x. So 3x times what is 9x squared? If you can't do that in your head, then just do that math. It's going to be 3x, so it's positive 3x. So now I'm going to multiply again, and I get minus 9x squared minus 12x, and that's going to give me 15x. And then I'm going to bring down that, plus 20, just like I brought down that one right there. And then 3x times what is 15x, and that's going to be 5. Again, just showing you here, you can always help yourself by doing that little math off to the side. Minus 15x minus 20. Woohoo! This one does divide evenly. So if I take my divisor and multiply it by my quotient, I'm going to get this right here. So we've been factoring using like t-charting and factor by grouping, but division is also another way of factoring. So my answer is just the quotient that I have at the top, because this question just asked me to use long division. Alrighty, so let's move on. What we were just talking about is what is called the division algorithm. It just says that if you take your divisor and multiply it by your quotient, and if you have a remainder, it's going to equal your function. So we say that if your remainder equals 0, then your divisor goes into your function evenly, and that your divisor and your quotient are factors. We just said that in the last problem. This is what it just says. Because my remainder is 0, my divisor and my quotient are factors of this polynomial that was given. It's kind of neat. Okay, the next thing we're going to go over is synthetic division. Synthetic division is used only when your factor is linear. So the highest power of x is 1. Okay, so again, this only works for linear factors. And when you actually do this, you're going to work with the 0 that's associated with the factor, and we'll go over that in just a second. So what we're going to do first is I'm going to show you the general form of this, and it's going to look a little confusing, but then we'll put some numbers with it, and it actually goes a lot faster once we put numbers with it. So x minus k is a factor. If I want the 0, guess what I do? I set it equal to 0. So this has, sorry, I just wrote that wrong. So the 0 is positive k. So that's what's going to go out here. And then you need to take your coefficients. So it's synthetic division, so it's shorthand. So we're not going to use the cubed and the squared and the x. We're just going to take the coefficients. So we have a, b, c, and d. And then what you're going to do is you always bring down that first one. So whatever that number happens to be, you bring it down. And then the way you fill in this spot right here is you multiply by k. So if you want to get to here, you times it by k. So in our situation, a times k would just be ak. When you're actually doing the problem, you'll get a number. So right here where it says diagonal pattern, you're going to put multiply by the 0. Or in this case, it's k. And then your next pattern, which is the vertical pattern, is you are going to add those down. So this would be b plus ak. But again, in these types of problems we're going to be doing, they're going to be numbers, so it's going to be really easy to do. So what would I do next? Then I'd multiply that by k. This is going to look really funny. bk plus ak squared and dot 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 all the way till I get down to here. And this right here will be my remainder. So that will be my remainder, but you asked me to divide, so where is my quotient? Whatever these numbers are your coefficients of the quotient. So you have to put back in the x's. And when you do that, you're going to start with 1 less than the original degree. So we're going to talk about that for just a second. If this is always a linear factor and I'm dividing, then what's x cubed divided by x? It would be x squared. So my quotient would start with x squared. If I had x to the 4th and I'm dividing by a linear 0, which is always just x to the 4th divided by x would be x cubed. So that's why you always start with 1 less than the original degree. And just, we said this, but we didn't write it in, so the vertical pattern is to add columns. Okay, so let's try this. Example 4 says to divide. So we are going to just practice real quick. I have a little post-it note here, just wanted to show you that x minus 3 is a factor. The 0 that goes with it is x equals 3. So when we use long division, we use factors, but when we do synthetic division, we do the 0 associated with that factor. So x plus 2 would be x equals negative 2, and if it's just x, it's going to be 0. So when we start this problem right here, it says to divide x to the third minus 7x minus 6 by 2. So this is the 0, said x minus 2 is what it says, is going to be x minus 2 equals 0, so x equals 2. So in this example, our number out front is going to be 2. And then the other thing you're going to want to pay attention to right here is it goes x cubed, and then there's missing an x squared, so we're going to need that 0 placeholder. So to set up our problem, we're going to put 2 out here. And then what I recommend that you do is just above here, start with your highest power of x and go down till you get to your constant. So that way you can fill this in properly. So the coefficient for x cubed is 1. We don't have an x squared, so it's 0. The coefficient of x is negative 7, and the constant is 6. So we bring down the 1. The diagonal pattern to fill out this one is to multiply whatever number this is by your k value or your 0. So that's 2. We add the columns together. 0 plus 2 is 2. 2 times 2 is 4. So that's going to add negative 7, and 4 is going to give me negative 3. And 2 times negative 3 is negative 6. Be careful with that. So my remainder is actually negative 12. What I want to say about this one is that x minus 2 is not a factor of this polynomial because we did get a remainder other than 0. So when we go to write our quotient, because this is just abbreviated form, we're going to pretend like we did x cubed divided by x, which would mean we would get x squared. So this is going to be 1x squared, or just x squared, plus 2x minus 3. And then what I encourage you to do is always write 12 plus negative 12 over x minus 2. In this situation, you could just write minus 12, but there are some situations where that's not always going to work for you, so I'm just going to show you guys that right here. Let's say, hypothetically, so this is not the answer to our problem, that your remainder was something like negative 12x plus 1. If you get a remainder of negative 12x plus 1, if you put your minus sign in front like it is on this one right here, you have to factor that negative out, because when we put the negative in front, it implies that it goes to both terms. So if you still leave this a plus, then you would get it wrong. So be careful with that. My suggestion is that you always just write it plus and then keep everything in the numerator, and you don't have to worry about it. Okay, moving on to the next little bit, it's the remainder theorem. So the remainder theorem is something that is pretty neato, but you also need to just practice this problem. I'm going to put tricky. It shows up on your test, and it says use the remainder theorem to find f of negative 4. Well, first of all, rather than just doing this the old-fashioned way of plugging in f of negative 4, which won't get you any points, you need to think about remainder theorem, and then you think, oh, remainder, that goes with division. So if that goes with division, maybe I should do division for the remainder theorem. And that's exactly what we're going to do. So rather than plugging negative 4 into this function to figure out the answer, we can actually just use synthetic division. So f of negative 4, so it's telling us up here in the definition that when it writes it like that, your k is negative 4, so we don't have to change the sign. When it's written in factored form, it'll have an x with it, so there's another clue. We also see that the highest power of x is x cubed, so I'm going to put my little visual reminder there. Then I have 3, 4, negative 5, and my constant is 3. Bring down the 3. This is negative 12, negative 8, 32, 27, and then negative 108, which gives me negative 105. Okay, great. What the heck does that even mean? The remainder theorem right here says that if you take a polynomial and divide it by its factor or by its zero, then the remainder will be the same thing as if you plugged it in. So this is telling us that f of negative 4 is negative 105. So that's a shorthand way to find function values. So make sure you study that. Again, you have this to fall back on, but because the problem on your test will say use the remainder theorem, if we don't see the division, then we know you're not using the remainder theorem. So, but if you notice, this is actually easier in this situation than this right here, because we got a lot of math going on here. 64 plus 20, negative 4 cubed is negative 64, and then we have to times that by 3, which is negative 192, and then add 3, and then we'll do all that math, and you'll see we'll end up with negative 105. So this is not the way we're going to do it on our test if it says remainder theorem. I just wanted you to see that. So that's a cool theorem right there. Whew, on to the back side. So for what value of k will the function right here, the p function, have a remainder of 4 when divided by the factor x minus 3? So this is just something that's really making sure you know what's going on, and I'm going to show you two different ways to do it. So for this right here, because it's a linear factor, I am going to use synthetic division. And then again, highest power of x is cubed, so I'm going to write that. So I have 3, and then the coefficient that goes with x squared is k. There's nothing with x, and then negative 5. And this tells us that it's going to have a remainder of 4. So here's the setup for it. What I want you to do is pause this and try and see if you can figure it out. Like I said, there's two different ways to do this, but this is a good apply what you know kind of problem. So give your brain a second to try and process it instead of just copying what I'm doing. So like I said, just pause it for a minute, try it, and then check back. I'm sure you can get it. I'm going to go ahead and continue. So I'm going to bring that down. 3 times 3 is 9. So here is the original way. Now remember, we add columns, so this would just be k plus 9. I can't simplify that because there's a variable. So then when I go to here, I'm going to multiply that. So that would be 3k plus 27. And thankfully that's a 0, so I can still get 3k plus 27. And then I'm going to multiply that, and I get 9k plus 81. And then what I do know is if I take this and add it to this, then I get my remainder, because that's the diagonal pattern. So negative 5 plus 9k plus 81 equals 4. So then I get 9k plus 76 equals 4 when I combine like terms. And then I move that to the other side, and I get negative 72. And then we get k equals negative 8. So here is another way that students did the problem when I had this as a group challenge in class. So we kind of have to ignore what's going on here, but this is what they did. Rather than starting like a typical problem with the left side like I did, the students, I'm just going to erase some of these things on this post-it just to be pretty clear. So these are things that we know going into the problem. We know we can bring the 3 down, but they are going, okay, this is 4 and this is -5, and those add together. So -4 plus what is 4? Well, that's 9. Okay, got that. So how do they get back over to k? Well, they know that to get from here to here, you have to multiply by 3. So if we're reversing the direction, you would have to divide by 3. So that is 3. And then they did the same thing here that they did in this one. 0 plus what is 3? That's 3. And then they reversed here. 3 divided by 3 is 1. And then they knew that right here, 3 times 3 is 9. So now what they have is k plus 9 equals 1, which is -8. So you can pick which method you prefer. Both of them work. This one has a little bit more algebra involved. Okay, so we've already talked about the factor theorem as well, that if when you plug in your k value you get 0, then it's a factor. And another way of just saying that is if you have a remainder of 0, then it factors, it divides evenly. So here's some pre-AP type questions here. Answer the following questions about factors and synthetic division. How could you show that x minus 2 was a factor of this? Show and explain your work. So how could I show it? I would just go like this, because it tells us to use synthetic division in the problem, and this is also a linear factor. So here's x squared, x, c, 1, -1, -2. Drop that down. And we get 1, 2 times 1 is 2, that's 1, that's 2, that's 0. Show and explain your work. So we have this. So this is the factor theorem that we're using. We're just going to say because the remainder is 0, x minus 2 is a factor. Alright, part B, is x plus 2 a factor of this polynomial? Show and explain your work. So very similar problem. So 2, -1, 3, and 8, -4. So you can kind of see where this is going, but right there we get -18. So we are going to defend our answer by saying because the remainder is not 0, x plus 2 is not a factor. We're going to be careful to say that it's not, the remainder is not 0, because sometimes students put because you got a remainder, but 0 is what we're specifically looking for. So if we have 0, then it's a factor. If we don't have 0, then it's not. So be aware of that wording right there. So then we move on to part C, which is very similar to what we just did, and it just asks you if these three factors are factors of that right there. And so rather than me doing all that work again, I'm just going to go ahead and show the answer here. So when you do this, 3, you get -24. Remainder is not 0, so it's not a factor. And then when you do -1, you get 0. And on part C, when you do 4, you get 0 also. So the remainder is 0, so both of those are factors as well. I just threw that up there. Pause the video if you want to take time to do it. That works. But it's very similar to what we just did in A and B, just some extra practice. Okay, D tells us that the function in letter C is a cubic function whose highest exponent is 3. Thus, there should be 3 zeros of the function. Based on your work in letter C, what is the other zero of f of x, and what is the multiplicity of each root? Explain your reasoning. So here's what we have right now. We have f of x, which is this function up in C, is x cubed minus 13x minus 12. And we know that if we plug in x minus 4, if you just look up to the part C portion, that when you do x minus 4, that's the quotient when you divide by x minus 4 is x squared plus 4x plus 3. So another way to write this function using something from the front, divisor times quotient, is what you started with. There's that way to write it, and then because this is 3 terms, I can t-chart it. There's that x plus 1 from part B, and then we also have x plus 3. So using division, we found the first factor, and then you can continue to use division to get the next factor, but it was just easier for me to t-chart that than to do it that way. So let's make sure we answer a question. It says, what is the other zero? So x plus 3 is the other factor. So x equals negative 3 is the other zero. And then each root has a multiplicity of 1 because it's a cubic function with 3 distinct zeros. So what is the multiplicity of each root? So we're going to put each root has a multiplicity, that's the number of times the factor appears, of 1 because it is a cubic function with 3 distinct zeros. So distinct zeros means that we don't have anything repeating. There's no x minus 2 quantity squared or anything like that. 3 different zeros. That's what distinct means. Okay, moving on to part E of the same question. And it says, if x minus 1 is a factor, what are the other 2 factors? And rewrite g of x in completely factored form. So with this one right here, you know that x minus 1 is a factor. So that's going to help you. Now, what I actually am looking at before I start this problem, which you could definitely do with synthetic division, is I'm looking at this and it has 4 terms and it looks like I'll be able to factor by grouping. So whenever I can, I'm going to try and factor by grouping. So the first 2 terms have an x squared in common. And if you look, the next 2 terms have a negative 1 in common. Why do I want to write it that way? Because then I can write it like this when I factor out what they have in common. And then I can do x plus 1 times x minus 1. And it says, what are the 2 other factors? Well, there they are, x plus 1 and 2x minus 3. And rewrite g of x in completely factored form. So there it is right there. 2x minus 3 times x plus 1 times x minus 1. So I can either have it in term form or in factored form. Now I am going to show you this way just because it's cool to see how this all works together, at least in my opinion. So highest power of x is 3, so I'm setting myself up so that I don't forget any of my placeholders. This one doesn't have placeholders because they're all numbers. I'm going to bring down the 2 1 times 2 is 2, that's negative 1, that's negative 1, that's negative 3, that's negative 3, and that's 0. So if you notice right there, what I have right here is that I'll write it. X minus 1 times 2x squared minus x minus 3 is my function. And then I could t-chart this right here. But what I want to show you is something kind of cool that you may not have known that you could do. But you could do this. I know that over here, I know that x minus 1 creates that 0, but I also know that negative 1 is there. So just so you know, you can continue your synthetic division. And if I know negative 1 is there, so I'm continuing it off the one before it. So I get another remainder of 0, and look, so from the first one I have x minus 1, that's from that top one, and then I have this one right here, which is x plus 1, and then I have my quotient, but because I went from x cubed to x squared, this is x to the first power, 2x minus 3. So you can also do that, and you can see that's the same thing that we got right there. Example 8 is just asking you to go ahead and graph this polynomial function. That's actually in part B. But you can notice that unlike question E, I have 4 terms, but I cannot factor it by grouping. So what I'm going to do is take the fact that they gave me a 0. So they gave me that negative 1 is a 0. So this gets repetitive if you have the hang of it. If not, then hopefully each question helps you get the hang of it. So we bring down the 15. Negative 1 times 15 is negative 15. Sometimes I can write faster than I can speak. So there we go. So what this tells me right now is that x plus 1 is a 0. I already knew that. It told me. But the remainder of this is x squared minus x minus 2. So there's my f of x function right there. There's another way to write that. The next thing I'm going to do is I am going to try and t-chart that. And that does t-chart. Or if you're magic square or diamond, whatever factoring method for trinomials that you use, you can use. So I get to there. So these are my 3 factors. It tells me to solve this equation, meaning it's equal to 0. So then I just set each piece equal to 0 and solve it. So I get negative 1, add the 2, divide the 5, 2/5, and negative 1/3. So those are the solutions there. And I just want to point out on this problem right here, if you have something that's quadratic and you're asked to find the solutions and you can't factor it by using a t-chart, then just use the quadratic formula. So sometimes it'll be that way. The last little bit just helps us tie in the lesson from yesterday. So we have to graph this. So the really cool thing is when we found the zeros up here, that's helpful for our graph. So the other thing that we want to do is the turns. So this one's going to have 2 turns because it's the highest power minus 1. To the right, it is a positive, so it's going to rise. To the left, the end behavior is, we have the highest power is odd, so it's going to have opposite end behavior. We have our x-intercepts up here, so y-intercept is the only other thing, and that's f of 0, which you get when you plug in 0 to your equation, so that would be negative 2. It's going to be your constant if it's in term form. So let's see, my x-intercept is negative 1, and then 2/5, which, you know, we'll call right there, and then -1/3, which we'll call right there, and then -2 for my y-intercept. It's going to rise, and it's going to fall to the left, and it has at most 2 turns, and there are no bumps because these all have odd multiplicity. They all show up only once, so they all cross through their graphs, so there'll be sign changes in the y, so you can kind of see that right there. And that is it for today's lesson. Have a great day.